on naming and formula writing. Compare what you got with what I got. Are there any comments, questions, concerns?
Why not?
Hey, Brooklyn. You betcha. Yeah, you did. Yeah, there was two. There was two. These guys have two.
Well,
You only got one?
we only finished when we finished.
Oh, when you finished, and so some of you didn't grab. Oh, even though I had two. You weren't here for this. Okay. There were two. And I told you to grab two. They were both out. When I told you to grab them, they were both out. Okay, well, those of you who grabbed, those of you who didn't, if you would like them, come over here. Okay. So, compare what you got with what I got. Are there any? They were both out on Friday. I did tell you to grab both. Are there any questions, comments, concerns about any of these? I'm going to slide this thing up. There you go. Oh, they're over there. Oh. I'm hearing lots of discussion. This is good. Is there anything from this front page anyone would like me to go over? If you were absent on Friday, there was nothing new. It was just one more. Yeah, no, it's over there on that table next to where Massey's sitting. Friday was nothing new. Friday was just another opportunity to practice one more time, putting it all together. On a short block, we're at a bunch of marking to do.
Yeah, that
Okay. There's a lot of discussion. Okay, for those of you who did it, here's the second one, or the other one. This one was just ionic. It did not mix in the covalence. The front side was ionic, the back side was covalent. Compare what you got with what I got. Question number 8, you could have had something different than what I got because HCO3 actually has two names. If you look at the chart on the back side of your formula sheet, it's either hydrogen carbonate or it can be just bicarbonate. I wanted to write less, so I wrote bicarbonate. Yes. Nope. It does not matter which name you choose. Aluminum only has one, so you do not need to include a Roman numeral. You only need to include Roman numerals if there are multiple possible charges.
Number one. That is CO.
Muller, did I make a mistake?
No. Oh, you don't feel. Oh. Oh.
Which one are you looking at?
Number 12?
Vanadium carbonate, that is a C.
No, I got it.
Brooklands, are we okay?
Oh, I mixed. Oh, I got it wrong. I got it wrong.
She's asking me first. So this is this ionic?
Yes.
And so when it's ionic, do we add the prefixes?
No, that's when it's covalent, you have prefixes.
So you don't add the point at me. You point at me. You're teasing me. I think
You only include prefixes.
when it's okay. For these like polyatomic ones, are they? How do you know if it's ionic?
To look at the charges. Sodium is positive, sulfate is negative. So if you have a positive and a negative, it's ionic.
Okay. Also, like the ion charges indicate whether it's
Ionic or covalent? Yes, it's all that.
Wait, so even if it's on the back of the thing, if it's positive and that one's positive, could it still be?
Positive and positive will never happen. It's going to be negative and negative.
Oh, okay. Okay, so negative and negative are covalent and positive.
Positive, negative are ionic.
So like not everything on the front, like say if you're looking at the table and then you go to the back and there's the other stuff, is it not always going to be ionic if it's one's on the table and one's on the back?
I don't want to say it.
98% of the time, that's going to be ionic.
Okay, so just check the charges so you make sure. Thank you.
Okay, Muller, did I make a mistake? Okay. You're wrong? Okay. I'm always willing to question. It could be me. In this case, it's doubtful that it's me because you're the second class to go through all my answers. And that other class is pretty strong. So if they didn't find a mistake, I've got some pretty strong. It's not that I have my own belief in myself. It's that I have belief in the 30 people who checked it last block. And if it made it past them, it's, you guys find my mistakes too, like on Tuesday mornings. I'm pretty confident that by D block my answers are right. Okay. Are there any comments, questions, concerns about this page? Right beside you, just walk past it. Is there anything anyone would like me to go over? Any questions or disputes, arguments or disagreements that need to be settled about this specifically? I'm less concerned about your interpersonal issues. Well, I'm not concerned. It's just, outside my pay grade. And then here's the back. This is the covalent compound page. Comments, concerns about covalent compounds. Only covalent compounds use the prefixes. And you can identify them by the fact that the covalent ones are both negatively charged. Comments, questions, concerns on anything off of this page? Yes, Matthew.
I got lead.
Because lead is capital P, lowercase b. So every time you have another capital letter, that's the start of a new element. So if you have capital P, capital B, that's not going to be lead. That's going to be phosphorus, and then either bromine or boron, or beryllium, or, right? So every time you see a capital letter, that's a start of a new element. Okay, so I'm not hearing an abundance of questions. I'm seeing lots of discussion, which is good. Generally, discussion means people are learning things. This is good. Would anyone like me to pause and allow them to continue the discussions? Okay. Then, how's that back table going? Evelyn and the Brooklyns. It sounds like a band. Evelyn and the Brooklyns. Are we good? Okay. Don't spend a lot of cognitive energy on that one because I'm going to give you another task right now. If there are no questions, or like on any of this stuff, there was, 60 questions I gave you on Friday, yes. Number 11 on this page, let's do it. Okay, so chromium, and it's got a Roman numeral of Vi and phosphate. So chromium, how do you do a question like this? You'd say, okay, well, chromium, first thing you do is you go to the periodic table and you say, okay, chromium, I found it, it's Cr. Then look at the charge. You'll see that chromium on that periodic table has a bunch listed. I don't have my periodic table in front of me, but it's going to have at least 2, perhaps 3 or 4. As soon as you see more than one, you take a look at the Roman numeral that's here. The Roman numeral will tell you which charge you're using. So this Vi is the Roman numeral for the number 6. So this is going to be chromium plus 6. So that's going to be the charge on chromium, and now you got to go ahead and find phosphate. The ending there, ATE, means that phosphate is not on the periodic table. If it ends in "ide," it's probably on the periodic table. If it ends in "ate" or "ite" or "eum," it's definitely not on the periodic table. You gotta go find it. You're gonna go look on the table of polyatomic ions. You want to make sure that the names are very deliberate. If it says phosphate, find phosphate. If it says phosphite, ITE, do not assume that that's a typo. Go find phosphite. If it's not on one table, it'll be on the other. So phosphate is PO4. PO4 also carries the charge of -3. So this thing's going to be ionic because I've got a positive and a negative. And so I like to use swap and drop. So I'm going to take the 6, I'm going to pull it down. I'm going to take the 3, I'm going to pull it down. That's going to be a 3, that's going to be a 6. And this tells us that 3 chromiums are going to go with the 6 phosphates. But the last step in swap and drop is always swap, then drop, then reduce if possible. Can I divide 3 and 6 by anything? Yeah, both by 3. So I'm going to divide by 3, divide by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So then when I go ahead and I actually name this thing, ladies at the back, it's going to be CR. When it is a 1, I'm not going to write the 1. I'm going to need PO4, but I'm going to need 2 of them. So whenever you need more than one polyatomic ion, you throw brackets around the thing and put the number on the outside. That is chromium 6 phosphate. A lot slower than perhaps you needed to do it. But that's kind of the whole thought process verbalized. Romina, does that make sense? Yeah. Yeah. Because ionic compounds always go in lowest terms. Covalent don't, but ionic do. So you'd never reduce a covalent compound, but you have to reduce an ionic compound. For those of you who did not hear what Asiya asked, she said, If you don't reduce, is it wrong? The answer is yes. Because ionic compounds always react in lowest terms. They just do. And so we have to put them in lowest terms. Covalent compounds do not. So for example, if you have a covalent compound, looks like this. Dinitrogen tetraoxide. Nitrogen's negative, oxygen's negative. This is a covalent compound. Di tells you that there's 2 nitrogens. Tetra tells you there's 4 oxygens. You do not reduce this. You write it exactly as the name says. Covalent, you do not reduce. Ionic, you do. Okay. Any other last minute questions, comments, concerns, queries, conundrums, or consternations? Okay, hearing nothing. I would like you to put everything away, except for your gigantic periodic table and a writing utensil. If you are sitting next to someone, I would like you to move your desk or move your body so you're not next to someone. Y'all are going to write me a quiz right now. Go slide yourselves around. Should probably get this off the screen. Do that. Ooh, I should probably pause my video. Do that. Pause. So I'll hand you guys back your quizzes, both of them, the Bohr-Lewis ones and the ionic covalent ones, the naming ones you just wrote for me. You'll get them all back on Wednesday because today we're going to start looking at chemical reactions and equations, and tomorrow I hope to get you guys in the lab. So find me this page, chemical reactions and equations. And let us talk for as long as we can until the bell goes. So, first blanks. It's literally the title. Chemical reactions. Thank you, sir. Chemical reactions are processes that involve chemical change. In grade 9, Science 9, chemistry, one of the first things you would have learned about is that there are several kinds of change. In grade 9, you would have talked about physical change and chemical change. There is a difference between the two. What is the difference between the two? What is a physical change? Who remembers? Just to review, what is a physical change? Brooklyn, N. That is, ooh. Color is actually evident, a color. How are you answering that question? Are you talking about color being a physical property? Or are you talking about color changing? So how something looks, okay? How something looks, so the color that an object has is a physical property, but a color change is actually indicative of a chemical change. What is a physical change? Or how is a physical change different from a chemical change? Evelyn. Rain. Okay, the process of evaporation is a great one. Evaporation is a physical change because whether it's a liquid or a gas, you still have water. H2O is H2O. It doesn't matter if I splash you with it, blow it at you, or throw it at you as a rock or an ice. Water is water is water. Okay, so a state change is an example of a physical change. A physical change, you still have the same substance. Whether it's ice, water as a liquid, or steam vapor, water vapor. Water is water is water. It's all H2O. So a physical change is not a chemical reaction. A chemical reaction is where you actually have something new. Some new substance is formed. And when we say a new substance, we mean it's new chemically. It's changed at the fundamental level. So something like, if I had iron, pure iron, you can get this. It's not hard to do. If you leave pure iron out in the world, what is pure iron going to do? Nope. React with the air, turn into rust. And how do you know that iron has rusted? What color? I mean, rust is also kind of a color, right? There's a reason why it's a color. Because it just is its own thing, right? And that the fact that the color is changing. If you have pure iron, it's going to look silverish, kind of a dark metallic color. You leave it outside in the wet and in the air, it's going to react with the oxygen that's present. A new substance is formed on the outside of that, iron oxide, rust. So you're going to have Fe plus O2. It's going to create something new. It's going to either be FeO or it's going to be Fe2O3, depending on what is present. Okay? So the act of rusting, and all metals do this. We have different names for it. Silver tarnishes. It turns kind of a dull silver and then black. That's because the silver is reacting with the oxygen in the air, turning into silver oxide. Rings will do this too. If you have like a white gold ring, it's plated with rhodium. That rhodium reacts. The rhodium starts to fade. It looks duller, and you get it replated. So chemical reactions, new substance is formed, physical change, chemically the same, even though a state change would be a good example. Chemical reactions can happen in a couple different places. They can happen both in what we call an open system and in a closed system. Chemical reactions can occur in both open and closed systems. And this is important for where we're going to go tomorrow. See you guys later. You have no homework? We'll see you later.